Okay, so this is where the difference quotient it becomes useful. We don't really need it if we're working with a linear function because we know difference quotient means slope, and we know the slope of a linear function is constant. But what if we had a quadratic? And this is about as complicated as we're going to get in college algebra, but this can be computed for cubics and all different kinds of functions. So here's a parabola x squared minus 2x. I just want to make some observations about this parabola before we go on and work with the difference quotient. A line has the same slope everywhere. But take a look at this parabola. It has different slopes everywhere. Here on the left portion of the graph to the vertex, it's decreasing, which would make us think that there would be a negative slope if we picked 2 points over here. After the vertex, it's increasing. We would expect a positive slope over here. So what that means is that the difference quotient is going to give us a way to find the slope at any given pair of points. Sometimes it's going to be negative, sometimes it's going to be positive, but it's definitely not going to be the same everywhere. So x is our starting point, remember, and h is going to move us away from x a little bit, and that's going to tell us what our slope is. So let's just imagine that x was over here at 2, and we moved a little bit away from 2 to x plus h, and we would expect a positive slope if we computed the difference quotient that way. But let's imagine this time that we started at x equals 0. We moved a little away, some h distance away, x plus h maybe over here. We would expect a negative slope. So the answer to the difference quotient will change depending on what side x is on and how far away we move. So we're going to get the formula first, and then I'll show you some examples with numbers. So to start off, you want to get this f of x plus h portion of the difference quotient formula. And so we have to do this very carefully. So here's our original function, x squared minus 2x. Everywhere that I see an x, so here, and also here, I'm going to replace those x's with x plus h. So can you see that I have an x plus h squared minus 2x plus h. So we have to remember how to multiply binomials. X plus h squared is actually the same as x plus h times x plus h. We're going to have to FOIL that, and I just copied this down here. So I'm going to FOIL this, or distribute. X times x is x squared, x times h is xh, h times x is xh, and I'm just writing it in that order so they're the same. H and h is h squared. I have to be careful here that I remember to distribute the negative. Negative 2 times x is negative 2x. Negative 2 times h is negative 2h. I'm going to look for some like terms. Looks just like maybe these two xh's. So x squared plus 2xh plus h squared minus 2x minus 2h is just one portion of my difference quotient. So that's my prep work. Now I'm ready to take that prep work and put it into the difference quotient formula. So here's our difference quotient formula from the previous video. F of x plus h minus the original function f of x all over this distance h. So I'm going to take this guy here, plug him in. There he is. I'm going to leave this minus from the formula. Come back up, sorry, here's the original function up here. Plug him in here. Now in this step, I just want to be careful again that anytime I subtract a binomial, I change both of the signs. So I haven't changed f of x plus h, but now I have negative x squared plus 2x. Now, a lot of things should cancel when you do this. So you may notice that the x squared cancels and that the 2x cancels. If they don't, check that you distributed the negative, because you really should get a bunch of things to cancel out here. And what I'm left with is 2xh, h squared, and negative 2h. Now I have an h here, I have two h's here, and another h here. So the key step here to simplify